So we're done with the bridge for now, so let's turn that off. I'm going to get rid of these lights, we don't need them. That was just so we could see those cracks in the road, right? So I want to continue with the horizontal cable. Okay, so I've already got it on here, so the class attributes, I'm looking at that. So we need to kind of clean up this geometry. What I want to do, I'm going to do a bullet sim, because these are cables which are moving, but they're very thick, heavy cables, so they're not going to be bending and flopping all over the place, which is why I'm not doing either a wire sim or a vellum sim. I'm just going to do this with RBD. So I'm just going to have kind of blocks for each, a kind of string of blocks for each of these cables, and have them constrained together. And then I'm going to use the simulation, the previous simulation, the road, the actual bridge itself, collapsing to guide the simulation of this bullet simulation, right? So first of all, we need to clean up this geometry. Again, we've got intersecting geometry there. So I'm going to drop a boolean and set it to union and plug that in. There we go. So that should have cleaned up the geometry. If we look inside, it's hollow now all the way. Now I want to do another connectivity stop, and I'm going to set this to primitives, because we've already got, you can see a class attribute there on the primitive. So just to overwrite that one, we'll set this to primitive, and you can see the results there. But if we look at these fences, you can see that these pieces in the middle are not connected. That's the only part of this whole thing that's not connected. So they're so small, and we're not going to notice them, so I'm just going to delete them. We could just select them and delete them, or we'll do it a bit more procedurally. Why not? Using our old friend, the measure sop, which I seem to be doing this all the time, but it's just a handy way of kind of isolating things. So per piece, and class is fine, and then delete. Okay, and then it's at area is less than, I don't know, 0.1. Perfect, that's got them. Okay, so I can see that we haven't deleted anything else, but all these pieces in the middle have gone. Perfect. Okay, so let's prepare our simulation geometry. So I'm going to drop a for each loop so that we can iterate over each of these for each named primitive, and we'll use that class attribute. Okay, and then go here. We can see we got the first one, and I want to simplify this geometry. There's kind of a lot of points there, so we don't need that. We can simplify it to make it cleaner geometry. So use VDB from polygons. So generate a VDB from this. Let's drop it down to 0.01. Okay, we're still kind of losing quite a bit there, but just to avoid going even lower on this, if we just peak the geometry out, if you remember, that kind of inflates the geometry a little bit. So let's do that to 0.01, and then that gives our VDB more information to pick up. Okay, and then convert that back into polygons. So convert VDB, set that to polygons, and then we've got kind of nicer, doesn't look very nice, but in terms of the simulation is cleaner geometry. Okay, and now we need to fracture this up. So create individual pieces for our bullet simulation. So I'm going to drop an add on the side here, this to generate my points. I like to do it this way when I want really just evenly spaced out points. So I use the points which are already there. So I'll delete the geometry, so I've got all these points, and then I'll just fuse them all together to give me nice even spacing between all of the points that we've got there. Okay, so if we just set this to a pretty high number, something like that, 1, you can see that's going to be each of my blocks. Now I'm going to have a string of pieces. Okay, and then drop a Voronoi. Fracture. Let that cut through. And if we take a look at the name attributes, then we can see we've got nice blocks all the way along. And to make this even, we could simulate with this maybe, but to make it even cleaner, nicer, I want to go over each of these blocks and drop a convex shape around it, right? So drop another for each within this for each, right? Don't worry about the name attributes here. We'll just name them up after down here. Okay, if we set the names in here, then we'll have duplicate name attributes, which is no good. So we're going to do for each again, and this time we'll go over the name attributes. Okay, so if we take a look at that, let's go to the first one. That will show one piece. There we go. Okay, and then drop a convex hull. There we go. And that will wrap around it like that, give us a nice, just clean shape. And I'd like to shrink it just a little bit. Pointer 1, just to leave us a little bit of space between all the pieces. I go to the end, and you can see the result. We've got just these nice string of blocks. Obviously, we'll constrain all these together, and then go to the end of this one, and we'll get a load of them together. There we go. So we've got our geometry there ready to go. So now we just need to constrain them together and set up our simulation.